Let's continue our discussion about DFA minimization. So in our last video lecture, we discussed the first method, which is equivalent theorem. So in this video lecture, we're going to discuss the second method, which is the Mahil-Nerode theorem or table filling method. So in this method, we're going to follow some simple steps to simplify our DFA or minimize our DFA. So let's start with step one. So in step one, we're going to draw a table for all pair of state, wherein the rows will be our states, our column will also be our state. But in this table, we're just going to utilize the lower part of the table. Okay? So because we know that BA is the same as BA here. So therefore, we don't need to utilize the upper part of the table, just the lower part. Okay, so now let's move on with step two. So in step two, we're going to determine the pair if one state is non-final and the other state is final. If we have this scenario, we're going to mark that column or that cell rather. Okay, so for example, so we have a pair B and A. So B and A, based on our DFA, they are both non-final, so we're not going to mark it. For C and A, are non-final state, therefore we're not going to mark it. B, C, non-final state, so no marking. D, A, no marking. B, D, same, non-final state, so no marking. And DC, both are non-final, so no marking. How about EA? E is final, A is not, so therefore we're going to mark it. B is non-final, E is final, so let's mark it. And then C, E, so C is non-final, E is final, so mark it. And then last, D, E. D is non-final, E is final, so let's mark it. So after marking this pair of state, which are final and non-final, we're going to proceed with step three. So in step three, we're going to determine the path of the pair state. If one of the pair path falls in a marked cell, we're going to mark the cell that we are evaluating. Okay, so for example, let's start with BA. Okay, so we have two values for B and A. It could be either 0 or 1. So let's start with 0. So if B is 0, where will it go? It will just loop within sub, so B. How about A? A at 0 will go to B. Okay, so is it marked? BB, we didn't use it, so therefore it's not marked. How about at 1? B at 1, it will go to D. A at 1, it will go to C. So again, based on the table, CD is not marked, so we're not going to do anything about BA cell. So now let's proceed with CA. C0, it will go to B. Well, A, it will just go to B. Okay, and then C at 1, it will just loop within itself. And A at 1 will go to C. So again, both B and C are not marked, so therefore we're going to proceed to the next cell, which is BC. Okay, so again, C at 0 will go to B, and B at 0 is still B. Okay, C at 1 is still C. Okay, but for B at 1, it's D. And C at D is again, it's not marked cell, so therefore we're not going to do anything on this combination of combination of state rather. Okay, so now let's proceed with DA. So D, if it's 0, it will go back to B. Okay, and A, it will go to B. D at 1, it will go to E. And A at 1, it will go to C. And BB, no marking, but for EC, we have a mark. So therefore, we're going to mark the A cell due to EC. Okay, so now let's move on with BD. So BD, B at 0 will just go, D at 0 will go to B. B at 0 will just loop within cell B. So D at 1, it will go to E. And B at 1, it will go to D. And based on the table, ED, this is the cell that corresponds to DE or ED, it is marked. So therefore, DB will also be marked. Okay, so now let's proceed with CD. So D at 0 is B, C at 0 is B, D at 1 will go to E, C at 1 will just loop within itself C. And again, EC is marked, therefore we're going to mark DC. Okay, since we have new marking, we're going to repeat this step. Okay, so check again for B. So B at 0 is B, A at 0 is still B, B at 1 is still D, and A at 1 is C. Is CD is marked? Is it marked? Yes. So therefore, BA will also be marked. Okay. How about CA? C at 0 is B, A at 0 is B, C at 1 is C, and A at 1 is C. Still, B is not marked, C is not marked, so CA will not be marked. So let's go to BC. So B, so C at 0 will go to B, B at 0 will go to B, C at 1 will go to C, and B at 1 will go to D. And CD is already been marked from our previous marking. Okay, so therefore CB will be also be marked. Okay, and since we have a new marking, we're going to check again CA. So, but unfortunately, B and C is not marked in our table, so therefore leave this blank. Okay, so in step 4, we're going to determine the grouping of our state. If all cells related to a certain state are all marked, so it will be, okay, so it will be one group. So it will be independent. That cell will be independent. For example, B. B, all related cells to B are marked, so therefore B will be one group. While for E, same as with E, all cells correspond to E is marked, so therefore E will be one group. Same as with D, all cells are marked, therefore D will be one group. But for AC, we have this cell wherein it's not one cell is not marked, so therefore AC will not be independent, but corresponding to this cell, that pair cell will be grouped as one. Okay, so it will be AC for this cell, B, and D, and E. And in reference to this diagram, we could now draw the DFA. So AC will be our initial state. Okay, it will accept R string, and then it will go to B if it's 0. But if it's 1, it will just loop within itself based on this part of the diagram. Okay, and then while in B, if it's 0, it will just loop within itself. If it's 1, it will go to D. Okay, but for D, if it's 0, it will go back to B. If it's 1, it will go to E. Okay. And in E, if it encounters 1, it will go to AC. And if it encounters 0, it will go back to B. Okay. And don't forget, whatever that includes this final state will be the final state. Okay. Don't forget that. So this will be our minimized DFA of this given DFA. Okay. So again, this is the simplified version.